So good morning. The theme today is retrofitting, strengthening and repairing, which are all kind of interventions to upgrade and rehabilitate existing structures. But what I'm going to talk about is that crucial step that we need to carry out first to understand whether such measures are needed, whether the structure might be perfectly fine as it is. And that's called structural assessment, where we determine or assess the capacity of a structure to resist the loads without reaching a limit state, such as ultimate limit state, collapse scenario in the extreme case. So what I'm going to talk about today is how the codes have evolved over time to allow us to carry out this process of structural assessment accurately and safely, and culminating in the latest documents that are being published in the second generation of Eurocodes. So this talk is about dealing with existing structures and specifically about codes. And we will get to the new second generation Eurocodes. But before that, a bit of history. Just going back a few thousand years, and let's look at one of the earliest building codes. So this is the Hammurabi Code. It dates to 1750 BC. It's a Babylonian legal text, which you can see in the Louvre Museum, and includes a wide variety of topics with quite harsh judgments based around the principle of an eye for an eye sometimes. And certainly placed the onus on builders to make sure the buildings were robustly constructed to avoid the severe consequences of a collapse. And you can see some of the laws there did certainly focus the mind. And while there are no calculations done back then, the idea that the potential consequences of failure should be a key consideration in the design and the construction were very firmly established. So the principles we can take forward from this are that if we can invest more in more reliable structures in design and construction, then we might avoid collapse later on. And there's this idea of the consequences of failure and the need to consider that, because the consequences and the associated cost of a structural failure can be severe. These are driving, questions of design and construction, and not explicitly about managing or assessing existing structures. And for that, we need to fast forward a bit. So this is St. Peter's Basilica in Rome. That was completed in 1626. And about 120 years after it opened, some deterioration was observed, some cracking, some distress was observed in the dome. And in 1742, the Pope ordered a survey to determine the causes of the distress and to devise some remedial measures. And interestingly, they used mathematical calculations and analyses to try and assess the structures, try and understand the causes of the distress and to recommend what measures could be taken. And this was pretty groundbreaking at the time. It was one of the first ever assessments of an existing structure that was based on calculations. And there was some controversy about whether or not the analysis was actually correct, particularly whether the behavior suggested by the analysis was consistent with the behavior of the structure as it was behaving in situ. And the quote on the screen, you can see on the left of the screen there, might have come from 1742, but many of you working in the field of assessment might recognize the challenge of being made to whether the theoretical analysis actually aligns with the reality. You can see that if it were possible to design and build St. Peter's Dome without mathematics, and especially without the newfangled mathematics of our time, it will also be possible to restore it without the aid of mathematics and mathematicians and mathematics. Michelangelo knew no mathematics and yet was able to build the dome. Heaven forbid that the calculation is correct, for in that case, not a minute would have passed before the entire structure would have collapsed. So there was some disagreement about the analysis of the causes of the distress, but there was a consensus and general agreement about the need for remedial measures. And they put 5 additional rings in 1743. And I think for me, the interesting thing about this is how we're still having the same challenges now. And it highlights how doing an assessment can be technically harder than doing a design, particularly regarding the methods of analysis and the need to be as accurate as possible. So in a design, we just need to show that the design is safe. But in an assessment, we need to go further and actually quantify the capacity as accurately and realistically as we can. Plausibility check is quite an important step, I think, in any assessment. Like, do I actually believe what my calculations are saying? Do they relate to a plausible limit state being reached? Does it correspond with my observations of what the structure is doing? So there's that. There's many other issues highlighted in this story that remain important in assessment. So there's the issues of how we combine the information about the actual structure and observations of its performance with the theoretical models and the approaches, how we account for deterioration, and the way that we can have confidence that we understand how the structure works. Inconsistencies between the more up-to-date methods for assessing the structure and the historic methods that might have been used to design it originally, and also achieving consensus with third-party checkers. All of these remain key challenges for us when we assess our existing structures. We need to feed into the way that the standards can cover the assessment of existing structures. So we've been talking more generally about buildings so far, but in the UK, it was in the need to assess and look after our aging highway bridges resulted in the most complete set of assessment standards that we have in the UK, which sit within the suite of documents known as the Design Manual of Roads and Bridges, or the DMRB. So in 1984, we had a new code for assessing bridges, which is BD21, was published. And that included a more realistic loading model, represented up-to-date highway loads, including some heavier vehicles that were previously designed for, and which recognized in assessment it might be acceptable to focus the calculations on the ultimate limit state, in most cases, as long as inspections can be carried out to confirm serviceability aspects are performing as expected. It also enabled the ULS calculations to focus on the load combinations that might be most realistically be expected to be critical. So, for example, in many cases, there's no explicit need to look at thermal actions because in a ductile structure, the displacements can be accommodated through yielding without affecting the collapse load. And for many typical motorway bridges, we wouldn't expect them to collapse as a result of wind actions. So there's some kind of simplifications that were permitted to allow us to focus on the most important aspects and avoid potentially over-conservative assessments of capacity that wouldn't have been very helpful. So the writers of that code recognized that if this was not done, a large proportion of existing structures could fail their assessments needlessly, which would not represent the true risks faced on the network or the priorities for investment. And it was particularly concrete bridges that pose particular risk because we have issues of corrosion and deterioration. And so to accompany BD21, there's a whole suite of client standards produced through the 80s and 90s, including BD44 for concrete structures. And that enabled concrete structures to be assessed accounting for deterioration and also to include the historic materials and products and detailing practices that were previously used in construction, but which are not included or permitted anymore in the modern design codes. So important to include all of that historic information as well as the up-to-date requirements. So the DMRB documents also showed how we could progress through levels of assessment, so from level 1 to level 2 to level 3, starting with the simple conservative methods and then progressing, if needed, to higher levels of assessment, which refined the methods of analysis, updated the input parameters to remove conservatism and hopefully achieve a better outcome. So in particular, for concrete structures, there was advice on how to take measurements of concrete strength from the actual structure, evaluate a worst credible strength, which could sometimes enable higher concrete strength to be used, compared with what was originally specified. There was also advice on proceeding from elastic analysis to incorporate some plastic behavior, such as using yield line analysis, which could demonstrate a higher load capacity in some cases. There's also a document about how to manage substandard structures and evaluate and control the risks. so that suitable interventions can be made, whether that's a reduction in the load that the structure can experience or in the need for modifications such as strengthening. And in the most extreme examples, by closing the structure where there's immediate risk to the public. So a lot of aspects that are simply not discussed at all in design codes, but which are very important if you want to pragmatically manage existing structures. So with the whole DMRB suite, the UK was ahead of many other countries by having a suite of documents specifically about how to carry out assessment and retrofitting of existing structures, taking account of the important differences between how we can manage existing structures and how we should design new structures. And while this was not technically a set of national standards, but rather a set of client requirements for a particular set of structure types, the highway bridges, documents do provide a detailed set of rules that can also be very useful when considering other types of structures, and they continue to be a valuable resource when assessing existing structures. So our experience in the UK with the DMRB has been extremely valuable in the development of the second generation Eurocodes, content for assessment, by expanding those principles of managing and assessing existing structures to cover all structure types. Then moving forwards to 2010, and we have the implementation of the first generation Eurocodes for design. And we have the scope of EN 1990 up there. And despite this clause in EN 1990 that's highlighted, which notes that in principle, the first generation EN 1990 is applicable for existing structures, the first generation Eurocodes did not include all the content that you would need to assess older structures, particularly those that were designed to previous standards and would not necessarily comply with the new Eurocode requirements. So this note saying that additional or amended provisions might be necessary where appropriate is doing quite a lot of heavy lifting here. Effectively, there's very little in the Eurocodes themselves about dealing with the key issues you need to consider for older existing structures, such as older materials, deterioration, older detailing practices that don't comply with the design rules, and all the other aspects that we've seen that are covered more extensively in the DMRB. So in general, the first generation Eurocodes were not really intended to be used for existing structures. And while we were using Eurocodes for the design of new structures, we did not use them in general for assessment of existing structures, because it just didn't cover how to do an assessment or any rules about how to deal with older structures with older materials and details. So this started an era where there was one set of standards, which is Eurocodes, being used for design, and potentially a completely different set of standards being used for assessment of existing structures, which might be the DMRB, if it's a bridge, or if it's a building structure, it might be the design standards that were used to design them originally. So this kind of inconsistency between the standards being used for design and assessment could be an issue, particularly if there's then a need to do some modifications. So it's not very convenient in those cases where the modifications are needed because of that inconsistency. And for this reason, in some rare cases, it was decided to invest some efforts in seeing how we could use the first generation Eurocode methods for the assessment of existing structures by expanding it and bringing in some extra rules as needed. And this is one of the first examples of that on the screen, which is the Hammersmith flyover, where you had severe deterioration of the post-tensioning tendons, which required a strengthening scheme using additional external tendons, which was done to Eurocodes. But the assessment was also done to the Eurocodes as well, which was very unusual at the time. This is kind of the first big example of that, supplemented as appropriate with additional or amended provisions. That was quite unusual, and in general, it wasn't done like that. In general, it was not convenient to use the Eurocodes for assessment. For buildings, we have an iStruct-T document, which is the appraisal of existing structures, which provides some guidance on carrying out appraisals of existing structures, particularly useful where there's going to be a change of use or there's a need to assess the existing building for a different loading or different configuration. And most of the content of this document, although it's from 2010, remains valid and is useful, covers a lot of the key issues that you'll encounter as excellent resource still. We've also got accompanying guidance from BRE Digest DG366, which links to the building regs and how issues like disproportionate collapse can be considered in existing structures. Again, that's very useful. We've also got some FIB documents on this topic. So Bulletin 80 considers how we can use different partial factors for existing concrete structures compared with new concrete structures. So the aim here is to demonstrate that there is sufficient reliability, the reliability being the measure by which the partial factors are derived. I won't go into detail about this, but that's a very useful resource if that's what you're looking to do. There might be, it's not the only way of demonstrating reliability. There might be other things you could do to get a better result before getting into the detail of this approach. But it's a good step forward. We also have Bulletin 111 more recently, which covers a whole range of issues you might encounter when assessing existing concrete structures, including deterioration and increased loads, and is a really valuable new resource to complement the other standards we have available, which I think we might hear some more about later today. We also have the new FIB model code, which was published in 2024. And the big step forward in this version of the model code is that it covers existing structures as well as new structures. So this means there's a lot of extra content that will be useful for understanding how existing structures work. It's not technically a standard, but it represents, the latest understanding, and it will feed into standards development worldwide. We had 2020, we had the updates to the whole suite of DMRB documents, and the documents used for assessing bridges, which we've mentioned already, were also updated. And so particularly CS454 for assessment of bridge structures and CS455 for concrete bridges. So a lot of these issues then were very relevant in the development of the second generation Eurocodes. So now we have the second generation Eurocodes, where in the second generation, unlike the first generation, we've got the incorporation of material about assessment of existing structures. So that has been achieved in some of the new second generation Eurocodes. And you can see the ones that have got a green tick here have got some content which are related to existing structures, not all of them. But you can see that concrete structures at the moment is the only structural material there where you've got specific content on how to do assessment of existing structures in the new Eurocodes. We also have the overall framework in EN 1990, which will now include a part 2 for assessment of existing structures, which will enable us to know how to carry out those assessments within the Eurocode suite and how to deal with the issues of partial factors and combinations and getting data from the structure and all of those kind of things. So the timeline for Eurocodes, you can see we're now approaching the culmination of over 50 years of work on Eurocodes. And we've got the implementation of the second generation documents happening in 2028. Many of them are already available, and the rest will be available next year, but not implemented in general until 2028. There's a lot of work happening right now to develop the national annexes, which will be needed for the UK implementation. So in 2023, we saw the second generation Eurocode 2, EN 1992-11, which was published. And that includes some content specifically relevant to existing structures. And it means that some of the key material specific aspects of resistance can be assessed using Eurocodes according to the material in some of the annexes. So we have Annex I and J are informative annexes. So Annex I covers assessment of existing structures. Annex J is strengthening with CFRP. So because they are informative annexes, we have some leeway over how and if they are implemented in the UK. And while Annex I is a big step forward in indicating how the Eurocode 2 resistance models might be adjusted and applied for older structures, it's not as extensive and complete as what we have in the DMRB already. So there may be some aspects of existing structures where the use of DMRB might be more useful than using Annex I, and vice versa. So if you're doing a national highways bridge project, it'll still be a requirement to follow the DMRB, but the national annex to EN 1992-11 will include some reference to the need to align with client requirements, particularly thinking about DMRB for highway bridges, but also other documents for specific asset types and clients. And also there's also going to be a permission in there, a recommendation in there to use the bond model for plain bars that we've got in CS 455, which is quite well established and accepted in the UK, but it gives a higher resistance than what's in Annex I of the Eurocode 2. So, but these Eurocode annexes, big step forward by having a consistent approach across the design and assessment to the different kind of resistance models, and developed by cross-European panel of experts. And it's the first time that we've had this content in a standard, and means that we can use consistent Eurocode-based approaches going forward. Now we come to next year, you'll see the publication of the new Part 2 of EN 1990, and this covers assessment of existing structures, gives the whole framework for the basis of design, and deals with those aspects that are not material specific, because the material specific aspects are covered in the relevant Eurocodes. So such as the way that the actions are combined and factored, how we can use the known information from the actual structure to improve the accuracy of the assessment and reduce uncertainty. So there's some aspects of this basis of design that are the same or very similar in principle for both design of new structures and assessment of existing structures. So there's been a need in the development of this document to link back to the main EN 1990 requirements for new design and not to duplicate the respective clauses. But as we've seen, there have been significant differences between design and assessment practices. So this document focuses on those differences. And the key aspect is, while there's now greater consistency between how we carry out designs and assessments, with both things now incorporated into Eurocode Suite, there is also the flexibility there and the guidance to treat existing structures differently when appropriate, maybe through the possibility of using or driving different partial factors, or gathering data and updating the models and the basic variables so it's more appropriate to the specific structure that's being assessed. So you can see a flow chart on the screen here, which is from one of the informative annexes in EN 1990 Part 2. And it gives a good overview of the whole process and is consistent with what we saw earlier in the DMRB, with very similar workflow to what we already do for bridges in the UK, but which is very applicable for any type of structure. And the detail of how you apply this will obviously depend on the scope of the assessment and the type of structure and the objectives of the assessment. So just now looking at the contents and some edited highlights of the new document for assessment of existing structures. I mean, it might seem a bit odd, but the first thing is to define what's meant by an existing structure. The definition itself is a bit of a circular definition, being a structure that exists effectively. So it was felt important that we included that definition, I think partly because there was a concern that the kind of relaxed rules for assessment shouldn't be used as a kind of backdoor way of getting relaxed design rules for a new structure. So there was a sense that we needed to have some way particularly in countries where the Eurocodes have a kind of legal status as legislation, for the national annex to give some definition on that point, because it's not something that could actually be in the document itself. So for that reason, we have this note which allows the national annex to give additional conditions for existing structures to which this document applies, if needed. And in this structure, we also have the principle that we saw earlier in the DMRB, that there's a focus on quantitative assessment and ultimate limit state. But the document also allows the use of qualitative assessment methods where the conditions for use of that are satisfied. And it also has some content on SLS as well, SLS verifications for those cases where it's needed to do SLS by calculation, such as where there's a change of use, or where there are existing serviceability concerns that are being investigated, or where there are some materials where you might need to satisfy SLS in order to, as part of the ULS verification. So there are some cases where that's going to be needed. So the scope of how far you go in these different sort of verifications, the scope of what is needed to be covered in the assessment is going to be structure specific and determined at the start of the process. So the idea of updating the variables, this is a word that crops up quite a lot in the new document, they're updating. And as it's the basic variables, but it's also the structural models. So updating these is one that it crops up a lot, and it's all about using the data and the observations from the structure to update the knowledge about the structure and improve the assessment effectively. So this is a key part of getting a better outcome, sometimes as part of an iterative process. We have a focus on the partial factor method, as you might expect, as well as acknowledging that there are other methods that could be used in order to carry out an assessment. But we're expecting that the vast majority of assessments will continue to be done using the partial factor method. So that is where the main focus is. And there's the facility in the document to either use the kind of default or fixed partial factors, such as the ones that you use for design or similar ones to the ones that you use for design, or possibly to adjust or calibrate the partial factors where the national annex permits that. And some guidance on how to do that. So the question of resistance models is a crucial one, particularly when looking at issues of deterioration and older materials and products that might be found in old structures. So in general, what we need assessment resistance models that account for the things that we might encounter in existing structures, which are probably not going to comply with all the design requirements in the Eurocodes for design, but that doesn't mean that they're unsafe. And that's a key point. So we do have some limited resistance content for assessment of concrete structures now in second generation, but not for other materials in the other Eurocodes. So we're still expecting that there'll be a need to look beyond the Eurocodes when doing assessment, particularly when assessing resistance where there might be materials and deterioration types that aren't covered yet. So this is an evolving picture. We'll still have some way to go before the Eurocodes provide a comprehensive set of standards for existing structures. But luckily in the UK, we have the experience and the existing materials and assessment to know how to deal with these issues, as we have done in the past. And I think there'll be the facility in the national annex to continue to provide that established guidance and references to suitable assessment documents. And so this also leads on to what the key purpose of the assessment is, which is normally to ascertain whether or not the interventions are required. So we have a section here on interventions, although the design of the interventions themselves are not covered in any detail. These are going to be very material specific and structure specific, and this is just the framework. But the framework is there So you have construction interventions and you have operational interventions, and it just gives you an idea of the sorts of things that could be done as a result of the assessment not providing the capacity that is required. And this is all content that's not normally included in design codes, but is kind of crucial when you're looking at existing structures. Then there's a lot of annexes as well, which provide some additional rules and information. I won't go into detail here, but you can see that depending on the scope of the assessment and the structure type, there's some content here that could be helpful with carrying out the assessments. So yeah, these new second generation Eurocodes will allow us to have a more consistent approach for existing structures with the way that we design new structures, and crucially with the way that we design the modifications that we might have to do as a result of the assessment. And for concrete, there'll be the relevant content we need to assess older structures, including use of plain bars, which isn't in the main Eurocode, and effective deterioration, and potentially also where you have details that are non-compliant for design. In some cases, there may be justification to adjust partial factors, and now we have a mechanism to do that. And it's not going to be fully comprehensive, but we'll need some additional guidance and documents for some structures. And for bridges, we'll continue to use the DMRB, which for concrete structures does have more content than what's in Annex I as well. So today, yeah, we've covered over 3,000, nearly 4,000 years of content on codes, from the Hammurabi Code, and then the controversial analysis of St. Peter's Basilica, and through all the methods used for assessing concrete bridges and building structures, right up to the latest second generation Eurocodes. There's always been, through history, there's always been a need to be particularly careful with existing structures, often going beyond what's necessary to design a structure to make sure we're considering the actual behavior, taking account of deterioration, historic material properties, data and observations from the structure to properly assess the specific structure as it is today, with the aim of understanding whether or not the interventions are needed. And while the field of structural assessment and codification remains an evolving picture, and I think it will, we now have this framework and some rules to assess concrete structures within this consistent suite of Eurocodes. It's not going to remove the need to use our judgment in understanding all the specific aspects of the existing structures and whether we need to go beyond the content that's in the standards, which has always been something that's really important for assessing existing structures, in order to fully understand and assess the structure. Just like St. Peter's Basilica, there might be some healthy challenges over the details and the refinement of the assessment methods. But if we can achieve consensus over the need or the lack of need for interventions, then that's a good outcome, which will enable us to be sustainable in the way that we extend the life of the structural assets, whilst also understanding the structural risks and the need for management actions. That's the end. Thanks very much.